Welcome to another episode of Catch This. My name is Trudy Ray. Long COVID is a chronic manifestation of SARS-CoV-2 infection, and it is most commonly characterized by lingering fatigue, brain fog, memory impairment, and confusion, among many other possible symptoms. It is a terrible, debilitating byproduct of this pandemic. Although it is unclear how the viral infection leads to long COVID, experts speculate that one or more of the following factors may contribute: an inability to successfully clear virus, a reactivation of latent or dormant viruses, a disturbance of the gut microbiome, continuing inflammation, and/or autoimmunity. Yale University researcher Akiko Iwasaki, David Putrino from Mount Sinai School of Medicine, and their colleagues recently explored some of these hypotheses in an attempt to identify diagnostic biomarkers that may be associated with long COVID. And in this video, I will discuss the results of that study. Don't go away. The study involved 4 groups of participants, with the experimental group consisting of both vaccinated and unvaccinated individuals with long COVID. The other 3 groups served as 3 separate types of controls: healthy, vaccinated, uninfected individuals, healthy, unvaccinated, previously infected individuals without long COVID, and healthy, vaccinated, previously infected individuals without long COVID. First, the investigators obtained blood samples from all participants and analyzed the samples for the presence of specific immune cells. They found that, compared to control groups, long COVID participants had lower levels of conventional dendritic cells and memory T helper cells. Conventional dendritic cells typically activate cytotoxic T cells, which in turn kill infected cells. Memory T helper cells are a central element of the adaptive immune response, where they help orchestrate downstream immune functions upon recognition of antigen. Long COVID participants also had increased numbers of exhausted T cells, which are no longer functional or capable of eliminating virus. Collectively, these results suggested that people with long COVID may have insufficient numbers of immune cells that are able to inactivate virus, and this would allow viruses to linger and continue replicating and circulating. The group is currently in the process of determining whether this assumption is true and whether long COVID participants do indeed have persistently circulating virus. More on that in the future. Previous studies have shown that patients with severe COVID-19 can have increased levels of functional antibodies directed against self-antigens that circulate outside of cells. In other words, extracellular autoantibodies, suggesting that SARS-CoV-2 infection can cause autoimmune disorders. But remember, this was in severe COVID-19 during the acute phase of disease, not long COVID. To identify a possible connection between autoimmunity and long COVID, the authors of the present study screened the collected blood samples for autoantibodies using a technique called rapid extracellular antigen profiling, or REAP. Among other applications, REAP allows one to assess antibody reactivity against a panel of extracellular human proteins known to contribute to well-studied autoimmune disorders. Interestingly, long COVID participants did not have increased levels of autoantibodies compared to control groups, suggesting that the autoantibodies detected in patients with severe COVID-19 may only be present during the acute phase of disease. However, REAP only assesses antibodies directed to extracellular self-proteins and does not provide any information regarding intracellular or non-protein specific autoantibodies. Therefore, at this point, it is too early to rule out a role for autoimmunity in long COVID. The authors also used REAP to detect antibodies against various viruses. They found that long COVID participants had antibodies against several other viruses in addition to SARS-CoV-2, and these viruses included Epstein-Barr virus, or EBV, a herpes virus that is well known for causing infectious mononucleosis, or mono, previously discussed on Catch This, episode 35. Check it out. Mono is a condition that is often compared to encephalomyelitis/chronic fatigue syndrome, also known as MECFS, and that is also compared to long COVID. However, because most adults have antibodies against EBV, and there was no significant difference in the percentage of EBV antibody positive participants between experimental and control groups, it is unlikely that a positive EBV antibody status contributes to the risk of developing long COVID. But there's more. The most interesting observation in the study was that compared to control groups, long COVID participants had about 50% lower levels of the steroid hormone cortisol. Cortisol is a potent anti-inflammatory agent, so it is feasible that a shortage of cortisol would lead to persistent inflammation and the long-term tissue damage associated with inflammation. In line with this reasoning, cortisol levels were highest in healthy, vaccinated, uninfected controls, lower in healthy, unvaccinated, previously infected individuals without persistent symptoms, and lowest in long COVID participants. In fact, using machine learning methods, the authors determined that cortisol deficiency was the single most significant predictor of a long COVID diagnosis. Low cortisol has also been implicated in ME/CFS, and treatment with hydrocortisone can provide some relief from symptoms. The authors are careful to note that the small sample size of 215 participants is a considerable limitation of this study. But still, the results offer some valuable insight that may apply to other chronic conditions. In contrast to public perception, long-term symptoms following an acute viral infection are not unique to COVID-19. And this is just one review, also by Akiko Iwasaki, going over some examples. Unexplained chronic syndromes involving similar symptoms to long COVID have also been reported after dengue virus, polio virus, SARS-CoV, the cause of the original 2002 COVID, simply known as SARS, chikungunya virus, West Nile virus, Ross River virus, Coxsackie virus, and influenza virus infections. Because these syndromes are associated with high public health and economic burdens, more work needs to be done to clarify their underlying mechanisms. Please check back in for updates on this work. But for today, that's it. Thanks again for listening. Will you just hit that subscribe button? My name is Trudy Ray. I'll see you next time on Catch This.